Hello, this is Dr. Hanaa Assil, and this is the paper 2C, October 2021 in IGCSE Chemistry Edexcel. Let's take a look at the questions and their answers. So the first question says, use the periodic table to help you answer this question. So you will need to look at the copy of the periodic table that is usually at the beginning of your Edexcel exam. Identify the element with atomic number 7. Remember, atomic number is the small number. Again, if you don't remember for some reason which one is the atomic mass and which one is the atomic number, there is a key in the middle of the periodic table that tells you. In this case, it is the one below that is the atomic number. Always remember the atomic number is the smaller number. So which one has an atomic number of 7? So you look at the periodic table and you find that nitrogen has an atomic number of 7. Identify a solid non-metallic element in period 3. So let us take a look at the periodic table again. Where is period 3? And we want solid non-metal. So the ones in period 3 are in those periods. Aluminium is a metal, silicon, phosphorus, or sulfur are non-metals, and they are all solids. Chlorine and argon are also non-metals in period 3, but they are gases, not solids. So the solids are silicon, sulfur, or phosphorus. Name an element in group 7 that is a liquid. Again, where is group 7? Group 7 is fluorine, chlorine, bromine, iodine, astatine. Which of these is a liquid? Remember that the only liquid non-metal is bromine. State the relative atomic mass of the element that is in group 4, period 4. So you look again at the periodic table. Where is group 4? That's the one that has 4 written at the top. So group 4 and period 4 is germanium. He's looking for the relative atomic mass. Again, remember the atomic mass is the bigger number, so it is 73. Which row shows the most reactive element in group 1 and in group 7? Let us remember again. Group 1, lithium, sodium, potassium, rubidium, cesium, francium. We said the most reactive one is the one below. So in this case, we usually say it is cesium. In this case, he's choosing francium. So francium, the one at the bottom of group 1 is the more reactive. Now group 7, we said which one is more reactive in group 7? The one up is more reactive in group 7. So this is the answer in D. The box lists words that may be used to explain the term saturated solution. I'm going to remind you that the word saturated is used twice in our syllabus with two different meanings. If I say a saturated solution, what does a saturated solution mean? It means it's a solution that has as much solute as possible dissolved in a certain volume of solvent at a certain temperature. So if I have water at a certain temperature and I try to dissolve sodium chloride, for example, some of it will dissolve at some point, no more will dissolve. That is when I have a saturated solution. Remember that when we talk about organic chemistry, we also say something about saturated, but in that case, in organic chemistry, saturated means it doesn't have a double bond. But here we're talking about a saturated solution, so it is the solution in which you have dissolved as much as possible of the solute at a certain temperature. Remember, at different temperatures, you can dissolve different amounts of the salt. Then the next question says the diagram shows the apparatus a student uses to make a saturated solution. So this is the student's method. He adds 4.5 grams of solid to a boiling tube. He measures exactly 10.0 centimeter cubed of pure water and pours it into the boiling tube. So now in the tube you have solid and water. Place the boiling tube in the beaker of water and heat gently, stirring the mixture continuously until all the solid dissolves. Then we remove the boiling tube from the beaker, allow it to cool, record the temperature when crystals start to form, because that is when all the solution has as much of the solid dissolved as possible. The recorded temperature shows when the solution becomes saturated. Name the piece of apparatus that the student should use in step 2 to measure exactly 10.0 centimeter cubed. What should I use? I should use a pipette. I could also use a burette. Suggest why the boiling tube is not heated directly using a Bunsen burner. Usually when we heat a test tube that has solids in it, we don't put it directly into the Bunsen burner. Remember, that is because you want to avoid causing the solution to boil vigorously and splashing out, or we say spitting out of the test tube. Then he says in step 5, crystals start to form at 26 degrees Celsius. Calculate the solubility of the solid in grams per 100 gram of water at that temperature. So if we go back, you will find that what he did was he added 4.5 grams of solid, and then he added to it 10 centimeter cubed of water. So that means that what he did was he put 4.5 grams in 10 centimeter cubed. Remember, for water, the volume is the same as the mass because the density is 1. So 4.5 grams in 10 grams of water. He wants how much will dissolve in 100 grams of water. So that would be the cross multiplication will give you 45 grams in 100 grams of water. The solubility curves for two solids A and B are shown. State the temperature when both A and B have the same solubility. Of course, when they have the same solubility is where their line or their curves meet. So at that point, what is the temperature? Well, the temperature is 71 degrees Celsius. Calculate the mass of B. So which one is B? That's the lower one. B will dissolve in 250 grams at 60 degrees Celsius. First of all, remember that this is the solubility per 100 grams of water. So he wants the solubility at 60. So at 60, I go up to graph B. I will find that from the graph, I have about 124 grams dissolved in 100 grams of water. He wants how much will dissolve in 250. So that will come out to be 310 grams. Suggest why the values for solubility of A and B may be less accurate at 95 degrees Celsius. Remember, as we heat to higher temperatures, some of the water may have evaporated, so we're not really measuring the solubility in the correct mass of water. Question 3 says sulfur dioxide and hydrogen sulfide are both gases. Remember that he usually gives you as much information as you need from the top of the question. The two gases react together to form solid sulfur and water. Complete the chemical equation. So what he's just telling you is write the state symbols. He already tells you that H2S and SO2 are gases, and you should know that water is a liquid. State why sulfur dioxide is reduced in this reaction. Remember, when something is reduced, that is because in this case, it has lost oxygen. The diagram shows apparatus used to compare the speed at which particles of the two gases diffuse. The two pieces of cotton wool and rubber bungs are put in position at the same time. A pale yellow solid forms. Explain how the diagram shows that hydrogen sulfide gas diffuses more quickly than sulfur dioxide gas. Where is sulfur dioxide and where is hydrogen sulfide? You can see that sulfur dioxide is on the left, hydrogen sulfide is on the right. The pale solid that forms when both of them meet is nearer to which one? Is nearer to the sulfur dioxide. That means which one has diffused faster or which one has diffused more quickly. That is the hydrogen sulfide. Since the yellow solid formed is nearer to the sulfur dioxide, then that means that the hydrogen sulfide particles diffused faster. Deduce a relationship between the formula mass of a gas and the speed at which a gas diffuses. Remember, if we look at the molecular mass of each of these, H2S has an MR of 34, SO2 has an MR of 64, And we said that H2S was the one that diffused faster. That means that the one that has lower molecular mass diffuses faster. This question is about ionic compounds. State the formula of the cation and anion in magnesium sulfate. You should remember that cation is the positive ion, anion is the negative ion. Usually, if we have any compound, the first part of it is usually the positive one, the second part is usually the negative one. If you don't remember it, you should know that magnesium, for example, is a metal. It has two positives because it is in group 2, so it usually loses 2 of its outermost electrons. Now, the next part is sulfate. Sulfate is the negative anion, and it has 2 negatives because its valency is 2. The number of charges is the same as their valency. The diagram shows the electronic configuration of a potassium atom and an oxygen atom. So he draws a potassium atom with 1 electron in its outermost shell. You know that potassium is in group 1. Oxygen has 6 electrons in its outermost shell. It is in group 6. And he's saying potassium oxide is an ionic compound. Draw the electronic configuration of potassium ion and oxide ion. So he already drew this for me. He said the potassium has 1 electron in its outermost shell. It is 2881. That's correct. Oxygen is in group 6. It is 26. Now, when I want to draw the ion, how do I draw it? You should remember potassium has 1 electron in its outermost shell. It will lose it. And the oxide ion has 6 electrons in its outermost shell, so it gains the 2 electrons in order to have a full outer shell. Each potassium ion has 1 positive charge. Each oxide ion has 2 negatives. A sample of solid potassium oxide is added to water. A reaction occurs and a colorless solution forms. When a few drops of phenolphthalein indicator are added to the solution, it turns pink. Identify the ion responsible for the color change. Remember, when it turns pink, that is because it is alkaline or basic. What makes something basic? If it has an OH minus ion, a hydroxide ion. Give a chemical equation for the reaction between potassium oxide and water. You should know that potassium oxide plus water will form potassium hydroxide, any oxide of a metal. Dissolve it in water, it forms its hydroxide, and then you need to balance. Explain why ionic compounds conduct electricity when molten or in aqueous solution, but not when solid. Remember, ionic compounds have ions. Don't mention electrons. Ions are free to move when molten or in solution, but when solid, the ions are not free to move. They are fixed in an ionic crystal lattice. So if we say why ionic compounds conduct electricity, it is because they have free moving ions. Okay, the diagram shows the apparatus a teacher uses to demonstrate electrolysis of concentrated aqueous solution of sodium chloride. During the electrolysis, 2 gases, X and Y, are formed. One of the gases produces a squeaky pop when tested with lighted splint. Of course, you should know which one gives a pop with a lighted splint. That is hydrogen. Now use ionic half equations to identify what is gas X and what is gas Y. Well, what you do is you look, what are we doing? We're doing electrolysis of what? Concentrated sodium chloride. So these are the ions that I have in solution. Now, which one will react at the positive and which one will react at the negative? Remember that at the positive is the anode. The one that goes to the positive is the negative ion. Now, which one is going to react? We have chloride and we have hydroxide. We said if we're talking about concentrated solution of chloride, it is the chloride that will react. If we had dilute, it would be the hydroxide that would react. But here the chloride will react. Now the negative ion goes to the positive and do what? Lose electrons. So the chloride ions will lose electrons, become chlorine. So gas X, which is formed at the positive, is chlorine gas. Now, which one goes to the negative? Well, the positive ions go to the negative. But if I have a choice between Na plus and H plus, we said the Na plus doesn't like to take any electrons back again. It is the H plus that will react, and the H plus will go to the negative and do what? And gain electrons. So it becomes hydrogen gas. So that means that gas Y is hydrogen gas. Okay, question 5 says metals are found in the Earth's crust, either as uncombined elements or in metal compounds in rocks. The method of extraction of a metal is related to its position in the reactivity series. The table shows the positions of some metals and carbon in the reactivity series. So this is the order of reactivity. The one at the top is more reactive than the one below. State the name given to rocks that contain metal compounds used in extraction of metals. We said if I want to extract a metal, I get something from the earth and then use it to extract the metal. That something is called its ore. So the rock that contains the metal compound and is used for extraction of the metal is an ore. Name a metal that is found as an uncombined element. Remember, in order to be found as uncombined element, that means it is not reactive. So the one below, least reactive, platinum or gold, you can dig up the earth and find platinum, or dig up the earth and find gold, but you cannot dig up the earth and find potassium, because potassium is very reactive. It is usually in the form of a compound, not as an uncombined element. Carbon extraction and electrolysis are two methods of obtaining a metal from a compound. Remember that we said in order to extract a metal, I can either do it by electrolysis or by reduction with carbon. Now, explain which method is most suitable to obtain calcium from calcium chloride. Now, in the reactivity series, where is calcium? Calcium is at the top. Now, in order to determine which method I should use, I should compare the reactivity of calcium to the reactivity of carbon. If it is more reactive than carbon, so calcium, for example, is more reactive than carbon, I cannot extract it by carbon extraction, because that would mean that I'm reacting carbon with a compound of calcium. That will not work. Carbon is less reactive than calcium. So I have to do it by electrolysis. So if he says, what is the method of extracting anything above carbon? It is by electrolysis. Why? Because any metal above carbon is more reactive than carbon and cannot be displaced by it. Explain without giving details which method is most suitable to obtain lead from lead oxide. Now I look for where is lead compared to carbon. Well, lead is less reactive than carbon, so I can react carbon with lead oxide, so that means I can get it by reduction with carbon. This is because lead is less reactive than carbon and it can be displaced by carbon. Explain using a label diagram why lead metal is malleable. Remember, we said all metals are malleable. Why are they malleable? Because we said this is the structure of metals. Metals are solids, so they are regular rows, close packed. But each of them has 1 or 2 or 3 electrons in its outermost shell that it really doesn't want. So these outermost electrons are sort of floating around. So we call them delocalized electrons. So the delocalized electrons are the electrons in the outer shell of each of these atoms. And that means that these are no longer just atoms, they are actually positive ions. So metals are made up of layers of positive ions surrounded by delocalized electrons. Why are they malleable? Because the layers of positive ions can slide over each other. Aluminium is extracted from aluminium oxide. The overall equation for the process is this. Now calculate the mass in grams. Please do not confuse yourself with the word maximum. It just means how much mass can I get. Calculate the mass in grams of aluminium that could be obtained from this mass of aluminium oxide. So we said for any chemical calculation question, The first thing is I use whatever information he gives me to get its number of moles. So what information does he give me? He says I have a mass of aluminium oxide. So I need to get the number of moles of aluminium oxide. Now, from mass, that means number of moles is mass over molecular mass. Calculate the molecular mass, and the mass has to be in grams. He gives me 1.275 kilogram. Of course, in order to change it to gram, I have to multiply it by 1,000. That means I have 1,275 grams. Divide by the MR, that gives you a certain number of moles. Now, the next step, the first step is you get the number of moles of what he gives you. The next step would be compare to what he's asking about. So I look at the equation. What is he asking about? He's asking about aluminium. He wants the mass of aluminium. So from the equation, if aluminium oxide has 2 in front of it, that means 2 moles of aluminium oxide will give how many moles of aluminium? Will give 4 moles of aluminium from the equation. And that means that the number of moles of aluminium is actually twice the number of moles of aluminium oxide. So it will be the 12.5 times 2. Now, from the number of moles, what does he want? He wants mass. Calculate mass. How do we get mass? Number of moles times MR, and that gives me 675 grams of aluminium. This question is about alcohols, carboxylic acids, and esters. Ethanol can be manufactured by reacting ethene with steam in presence of phosphoric acid catalyst. Now, which row gives the correct conditions of temperature and pressure? Again, remember this equation. Ethanol made from ethene and steam. So I have ethene plus water at a very high temperature. That is what we call steam. This will be an addition reaction in which the double bond is opened and I put H on one carbon and OH on the next carbon, so it gives me ethanol. Now, what are the conditions for making ethanol from ethene? We said phosphoric acid catalyst. He already said that at the top. What is the temperature? The temperature is 300 degrees Celsius, and the pressure is somewhere between 60 and 70 atm. So the answer here is C. Give the displayed formula of butanol. Again, remember, displayed formula means all the bonds and all the atoms shown. Butanol, how shall I draw it? Well, but means how many carbons? But means 4 carbons. What does all mean? It means it's an alcohol. An alcohol has what? It has OH, OH alone, not OH and C double bond O, for example. So this is the displayed formula of butanol. Remember, each carbon must have a total of 4 bonds coming out of it. Ethanoic acid is a carboxylic acid present in vinegar. The concentration of ethanoic acid in vinegar can be found by titration with aqueous potassium hydroxide. So he gives me the equation. In a titration, a 25 centimeter cube sample of vinegar is neutralized by 45 centimeter cubed of COH of concentration 0.4. So he's given me 45 centimeter cubed of COH, that's the volume. Concentration of COH, that's 0.4. And he is asking for what? He's asking for the concentration of the ethanoic acid. So again, he gives me information about COH. So the first thing I should do is get number of moles of COH. How do I get the number of moles? Concentration times volume. That gives me the number of moles of COH. Then I go back and relate it from the equation. He's asking about what? About ethanoic acid. Well, the reaction says 1 mole of ethanoic reacts with 1 mole of COH. So the number of moles of ethanoic is the same as the COH. And then what is he asking for? Concentration. Concentration is number of moles over volume. So that is the number of moles over the volume. Remember, the volume has to be in decimeter cube. That means we divide the 25 centimeter cube by 1,000, and that gives me the concentration of ethanoic acid. A sample of vinegar contains 0.003 moles of ethanoic acid. Calculate the volume of carbon dioxide gas formed. So again, he gives me already the number of moles of ethanoic acid, so I don't need to sit down and calculate it. He gives me that I have 0.003 mole of ethanol. So the first thing I should do is relate it to the carbon dioxide from the equation. Can you see the equation? The equation says 2CH3COH will give at the end on the right 1 mole of CO2. And that means that the number of moles of CO2 is half that of the ethanoic acid. So if it is 0.003, then it is half of that. So it is 0.0015 mole of CO2. Now, what is he asking? He's asking about the volume. The volume is for a gas. Remember, the volume of a gas is number of moles times. We said 24 decimeter cubed or 24,000 centimeter cubed because he wants it in centimeter cubed. So that is the volume of carbon dioxide gas. Alcohols react with carboxylic acids to form esters. Which alcohol could react to form the ester ethyl propanoate? Remember that the word ethyl is the part that was alcohol. So let's just review what we said about esters. We said ethyl propanoate. That means the part that is propanoate, that was the part that was acid. So that part is the part from the propanoate, that is from propanoic acid. And then when he says ethyl propanoate, that means that part was ethanol, was the alcohol. And that means that this ester was actually made from propanoic acid and ethanol, which is C2H5OH. Polyesters are formed in condensation polymerization reactions between dicarboxylic acids and diols. State one difference between condensation polymerization and addition polymerization. Okay, let us review this just a little bit. What did we mean by addition polymerization and what did we mean by condensation polymerization? Remember, addition polymerization is where I'm starting with a monomer that is unsaturated. So for addition polymerization, the monomer has C double bond C. That is one difference. If you want a second difference, then the polymer is the only product. When I do addition polymerization, I start with an alkene and my only product is the polymer. But when we do condensation polymerization, first of all, I start with monomers that have functional groups on both ends. So a diacid, a dialcohol, I join them together by the removal of a molecule of water. So we said we remove OH from the acid, H from the alcohol, and join to form a polyester, for example. So this is condensation polymerization, where the monomers have functional groups on both ends. They're not alkenes, and I join them by the removal of small molecules such as water. The repeat unit of a polyester is this. Give the displayed formula of each of the two monomers needed to form this polyester. Again, this polyester was made from a diacid and a dialcohol. Which part is the diacid? Remember the part that has C double bond O? That was the part that was acid. So an acid C double bond OH from one end and C double bond OH from the other end. Now, the other part here, this was the part that was dialcohol or diol. So it was actually an OH on one end and OH on the other. So these are the two monomers that we started with to make the polymer that he draws on top. Now, give one advantage of biopolyesters. Remember, we said biopolyesters are the kind of polymers that are biodegradable. Remember, we said most polymers are non-biodegradable. That means they are not broken down by bacteria. But the biopolyesters are types of polymers that are biodegradable. Question 7 says hydrogen gas and iodine gas react together to form hydrogen iodide, and he gives you the equation. Now the pressure of an equilibrium mixture of the three gases is increased. So this reaction, I'm going to increase the pressure. Now remember, we said for any reversible reaction, when I increase the pressure, it should go to which side? increasing the pressure goes to the side that gives less number of molecules. Now, here he's saying predict the effect of increasing the pressure on the yield of hydrogen iodide. So if I increase the pressure for this reaction, will it go forward or will it go backward? We said it should go to the side that has less. Well, if it goes forward, it will give me 2 molecules of HR. If it goes backward, it will give me 1 molecule of hydrogen and 1 molecule of iodine. And that means that both of them are the same. There is equal number of moles on both sides of the equation. So actually, there is no effect on the yield. It will not give me more of HI or less of HI. Remember, the word yield means the mass or the amount of product. So if I increase pressure for this reaction, there is no effect. It will not go forward and it will not go backward. Why? Because it has the same number of moles on both sides of the equation. Then he says a catalyst is added to an equilibrium mixture. Remember, we said, what does a catalyst do? In general, a catalyst increases the rate of a reaction. And for the reversible reaction, we said the catalyst speeds up both forward and backward reactions. So actually, it will not make it go forward and it will not make it go backward. So there is no effect on the yield. So a catalyst for the reversible reaction, the catalyst does not have an effect on the point of equilibrium. It makes the reaction faster, so it makes it reach equilibrium faster, but it does not make it go more forward or more back. Then this is a typical question that you will get in every paper. Use the equation and the data in the table to calculate the change in enthalpy delta H for this reaction. So he gives me an equation at the top and he gives me information about the bond energies. So the first thing I do is I look at the bonds. What do I have? H2 means I have 1 bond between 2 H's. F2 means I have 1 bond between 2 F atoms. And 2 HFs. So I have HF and HF. These are the ones that I have. And we said in order to use bond energy to get delta H, we calculate the amount of energy needed to break the bonds. This is a positive number. So to break an HH bond, I need 436. To break an FF bond, I need 158. And then when the 2 HF bonds form, they release energy. So that is a negative energy. So remember, it is reactants minus products. And the final answer here is a negative sign. So you need to put a negative sign. If it is a positive number, you have to put a positive sign. So delta H must have a sign. Now this reaction came out in negative. So if I'm drawing the energy level diagram, how would the energy level diagram look? Well, negative means it is what? Exo or endo? It is exo. It's an exothermic reaction. That means the reactants give out heat. That means the products have lower energy. And he says, label the enthalpy change. You should have an arrow going down from reactants to products. That is your delta H for the reaction. And that was the last question in this exam. I hope this was helpful to you. Thank you for listening.